to the only operational revenue generating steam powered machine shop in America. This is video number 17 and I hope you enjoy it. I kind of put this one in ahead of some of the others that I had planned because I had got this job in the shop that I thought was interesting, making a gear for a steam road roller from scratch. But we've been kind of plodding along on the Morris Machine Works steam engine, and Tom has been busy making special bolts for it. We'll show you some of that, and the shop's been running fine. We've had no problems really. We got had some rain and got our rain barrels filled back up. I got a couple more loads of junk wood from a fella down the street that's renovating an old house, and we had a couple visitors. Actually 3 visitors from a little downstate New York. Paul Jacobs, Mike McEwen, and Ed Wheeler had been in contact with me and decided they want to make a little trip up here, and spent most of the day in the shop. And we were cranking things out, and by the way, thanks for lunch, guys. Come back anytime. When we got to making this gear, I discovered that although I was very fortunate to find the correct cutter, it's a number 3 cutter, I think, for this gear we're making, but the only 1.25" arbor that I had for the old Brown and Sharp mill was in pretty bad shape. It was evidently a shop-made arbor, and it was somehow about 10 thousandths undersized, so the cutter was kind of clanking around on there. But I took it over to my friend's cutter grinder shop, and we ground it up and got it really sharp, and you'll see it's really only cutting on about 4 teeth, and I really need to make a new arbor. It's also the spacers here, the edges of them were in bad shape, and I tried to true them up on the lathe, and I got a lot of the run out of it, but it's still off a few thousandths. This is a number 10 Brown and Sharp. So if anybody knows where there's some number 10 Brown and Sharp arbors that somebody would part with, I'd appreciate knowing about it. It will save me a lot of time making them up. So we'll get right to it. The thought came to me the other day. I had a viewer on one of the comments that said, you know, in times like these, steam will rule again. So think about that.
You're going to make a trial pass using the red line first, just to see where I am on the checking with the thread gauge. Okay, not enough. Okay, pull it back a little more. Okay, and I guess we'll check it with the thread gauge now.
Down.
Looks good. A little oil.
Okay, the next thing is we got to make a gear for this road roller steering deal. This is the pinion gear right here that goes on the end of the shaft, and it drives this counter shaft that has the two clutches on it off of the engine crankshaft. And this is the factory drawing from case, I don't know, about 1918, something like that. And it shows this gear as a 19 tooth gear with a 4 diametrical pitch, so that pretty much locks it in. Now they're saying that the overall diameter is 5 7/32. Well, it's 5 219. So I just double checked it here, and by the formulas, the diameter is the number of teeth plus 2 divided by the pitch. 19 plus 2 is 21, divided by 4 is 5 1/4. So there's about a 30 thousandths difference between what they got in their drawing and what the actual gear formulas make it to be. So I'm going to go with the drawing, because I'm afraid there's a center line thing that it might make the gear too tight. So I'm just going to go by what they say here in this drawing. So the hole depth, like we figured out before with the gears for the lathe, that's called D plus F, or D prime plus F, is just a constant 2.157 divided by the diametrical pitch, which is 539, which is also stamped on the gear. They figure it out for you, and if you look on the side of the gear, or not the gear, the cutter, you'll see 0.539 shown right there. And this is the dividing head work, same deal as before. The 40 is the constant for the dividing head over 19, which is the number of teeth that we want. So you just multiply the top and the bottom, or divide the top and the bottom, until you find some kind of fraction that you got a hole plate for. So if you multiply the 40 by 2, you get, by both of these by 2, you get 80 over 38. Well, I don't have a 38 hole plate, so I multiplied them both by 3, and you get 120 over 57, and I have a 57 hole plate for the dividing head. So it's going to be 120 holes on a 57 hole plate. So that's 2 complete turns would be 114 plus 6 more. So it's 2 complete turns plus 6 holes on a 57 tooth plate. That's how it works out. Not really complicated. I got my piece of stock already. It's a piece of 5 1/4 diameter, 4140 annealed, and I hope I can get through it, because these are pretty big teeth.
So here's the plate, and right up here, this top row is 57 holes around the outside here. So that's the plate we'll use in the dividing head. And here's the cutter. It's a number 6 cutter, which is from 17 to 20 teeth. 17 to 20 teeth, and we're cutting 19, so that fits. And then it says the TD, or total depth, is 5.539. So everything is figured out. All I got to do is grind this. It's a little on the dull side. This is the stock piece of 4140.
So we'll get going on it. The print shows a boss on here, 3 inches in diameter and an 1/8 inch deep. And back here. Get it set up to bore. This hole's got to go to 1.625. I got my tool ground up and I pulled this back in so I don't have so much sticking out here. See how it goes. Just a rough deal to see where I'm at. I got a long way from there.
Here's the gear blank machine. We're gonna broach a 3/8 keyway in it. Enough stroke to make it all the way through. Something else. A little bushy. There it is. Okay, so you got to put shims in here. It's going to take 3 passes. Here's the first shim. Three-eighths keyway.
Okay, so the gear blank is set up in a shop-built arbor, and to center the cutter over the top of the gear, we just use some little feel here on that side, and a little feel on this side. Okay. Dividing is set up with the right plate, and I'm gonna nick the blank and then work it around the 19 teeth and see if it comes back in the hole. Finally made it around to the last two. That should be right down the list. Well, that was a long way around. Watch your foot. Yeah, there's the gear. A little bit of deburr work, and we'll have it done.
Well, that's about it for this time. Thanks a lot for the comments and the suggestions and the subscriptions and all the emails that I've been getting from all of you. I'm gonna leave it with a couple of clips that I took from a field trip that I went on a couple weeks ago out to Jonas Stutzman's shop in Middlefield, Ohio. Jonas is in the business of rebuilding and building from scratch replacement boilers for all kinds of steam engines, locomotives, steam traction engines, stationary boilers, everything, and just has an awesome shop out there. It's a family-run operation, and they're Amish, so there is no electricity on the premises, and he puts on a sort of a customer appreciation day once a year. He calls it his sawing day, and they get his sawmill up and running, and they put 4 or 5 different engines on it, and just listen to these 2 engines. The first is an advanced Rumley, and these engines are really tweaked out. I mean, the valve timing is spot on. They're running 150 to 175 psi pressure, the way they were intended to be run, and right up to operating RPM, and it sounds a little different than it does on a sawmill and your average steam show around the country. So with that, we'll say goodbye and catch you on the next video.